So the warm-up problems you just worked on were intended to be a refresher on the order of operations. The order of operations refers to the sequence in which we evaluate a mathematical expression. The order is parentheses first, followed by exponents, then multiplication or division, and then ending with either addition or subtraction. An easy acronym to remember that if you forget the order sometimes is just PEMDAS or PEMDAS. And so the reason we're kind of looking at the order of operations and refreshing you on that is because in Math Counts competitions, there's problems that are pretty common which define new operations. So for example, you might encounter a problem that says define A heart B to be equal to A plus B all times 5. And that might seem a little confusing, but really the operations that you're already familiar with, all of these, multiplication, division, addition, subtraction, a lot of those are similarly defined. You've just kind of internalized that definition. For example, if you look at what A times B means, you don't really think about that, but really what A times B is defined as is A, and so on, B times. So we're going to look at some of these problems that have these new operations defined. They're previous math counts problems, and we're going to apply what we know about the order of operations to solve these problems. So let's look at the first problem. And the first problem reads, define the operation A hashtag B as A squared plus B. And then what is the value of quantity 2 hashtag 1 hashtag quantity 2 hashtag 1. So just diving into this, we're going to continue to just follow our order of operations, which always says parentheses first. So let's look first at this 2 hashtag 1 in the first set of parentheses. And all we're going to do is just plug it in into our newly defined operation. So we're going to compute 2 hashtag 1 equals 2 squared plus 1. Then exponents come next, so we get 2 squared is 4 plus 1, and then we add to get 5. So this first term is going to be 5. So we have another set of terms that's in parentheses here, but don't go ahead and compute that, because if you'll notice, this is also 2 hashtag 1. So we're going to know that these two are going to be the exact same quantity. So we can go ahead and just plug in the 5s in both of those. So now we brought it down to 5 hashtag 5. So again, we're just going to plug that in to 5 squared plus 5. Exponents first, 25 plus 5. And then we get a final answer of 30. All right, so that wasn't too bad. That's everything you already knew about order of operations. It's really just plugging stuff in. So let's look at another problem. The second problem says, if A star B equals A plus B minus 1, what is the value of 5 star 5 star 5 star 5 star 5? So you might be tempted to just jump in and start evaluating this. You just got to plug it in, right? Just keep going. But as is common with math counts problems, it's good to kind of take a step back and just kind of evaluate this and see if there might be a better strategy here. So what I'm going to challenge you to look at is what would happen if we just looked at A star 5 on its own. And if we plug in just A star 5 into what we have here, we get A plus 5 minus 1, or A plus 4. So in other words, every time we're doing this star 5, we're really just adding 4. So if you look at this, you'll notice that we have 1, 2, 3, 4 star 5 operators. So you don't need to go through and continuously do this calculation. We now know that this is going to be 5 plus 4 times 4. So then we get 5 plus, doing our multiplication first, 5 plus 16, and then our final answer of 21. All right, so let's look at one more with using that new defined operators concept. So our third question is, if A diamond B is defined as A times B plus 3, what is the absolute difference between quantity 10 diamond 11, diamond 12, and 10 diamond 11, or quantity 11 diamond 12? So similar to the last one, let's just take a step back. You want to dive in and start computing this, but there might be an easier strategy. So first, a big thing that you want to ask yourself when looking at math counts competition questions is what am I looking for? And here what it's actually asking for is not the value of these terms, but the absolute difference of these terms. So that's an important thing to notice. So then you can also notice that there's some similarity between the numbers that are being plugged into these. We have 10 in both, 11 in both, and 12 in both. But the order in which they're being used in the operations is different. We can tell this based on the parentheses. So this was a countdown round problem on the nationals, and the countdown round problems, you can't use a calculator and they're intended to be done very quickly. So if you went through and started computing all of this out and found the actual value of this expression, and computed this all out and found the actual value of this expression, it would probably take you a lot of time. So what we're going to do is use our distributive property to kind of figure out what the terms in this expression are going to be. So follow along with me here. So if we look at this, and let's just look at our term in parentheses first, without actually computing it, we know it's just going to be 10 times 11 plus 3, and then we're going to have this diamond 12. So similar to multiplication, we can kind of, since this is going to be multiplied, distribute these to our two terms. So then we can come up with 12 times 10 times 11 plus 12 times 3 plus 3. And that's what is going to be the ultimate answer, but we don't need to do that computation quite yet. Let's do the same thing over here and see if we notice anything. So if we go over here, we're going to get 10 diamond, and then we compute this, 11 times 12 plus 3. All right, then distribute this 10 times 11 times 12 plus 10 times 3, and then plus 3. All right, so again, we're looking for this absolute difference. So what you're going to notice is that the first term over here is essentially 12 times 10 times 11, and the first term over here is also that. So those two are actually equal. So what's going to happen when we subtract these two terms? These are going to cancel out. So we don't even need to compute those because they're just going to eliminate each other. And then if you also notice, the last two terms are both 3. Similarly, those are just going to cancel each other out. So all we really need to look at are our middle two terms and the difference between them. So we end up with 12 times 3 minus 10 times 3, or 36 minus 30, which gets us 6.